Hi everyone. Today we are going to explain how the exchanger are involved in the power generation. So I'm Juan Camilo Mancera, he's Santiago Padilla, and he is Diego Ángel. So the power generation consists in the transformation of some kind of energy, like thermal energy, nuclear energy, chemical energy, or solar energy, in electrical energy. So for this exposition, we are going to focus on a thermoelectric power plant, because in this thermoelectric power plant, we will see how the heat exchanger are more involved in the power generation. In this plant, they are involved two important thermodynamic cycles. The first one is the Brayton cycle, and the second one is the Rankine cycle. But before I explain this thermoelectric plant, my partner Santiago Padilla will explain you the types and how it works. The type the heat exchanger and how it works in the power generation.
Well, we can find four kinds of or types of condensate of power. So the first one is condenser. A condenser is a heat exchanger in which it is desired that the fluid that passes through it change from the gas phase to the liquid phase through the exchange of heat. Condensation can be produced here by two parts. The first one is with air, with the use of fans, that means aero condensers, or the second part is with water, semi-closed circuit, with a cooling shower, with the use of a cooling shower. Now, the first part of this presentation is air-cooled, that is divided into types of convection. The first one is natural convection, and the second one, forced convection. Natural convection is characterized by three items. The first one is quantity of air is poured, requires less condensation area. The second one is used in freezers, in refrigerators and freezers, and finally is located on the back of the equipment. The second one is forced convection, that generally use fine tubes, and they use one or more fans to force air to pass through. Now in this slide we can see the two types of condensers of air-cooled or water-cooled. There is mountain chassis compressors and condensers, and remote condensers and fans. This one is this one that you can see here, and the second one. And the second part is water-cooled, that is divided into methods. The first one, wastewater system, and the second one, recirculated water. Wastewater system, water comes from rivers and lakes, and after circulating through the condenser, the water is returned to the sewer. And finally, recirculated water. The water is carried by pumps and tubes to the cooling shower, and this is to reduce its temperature and reduce the water in the process. You can see in this image the kinds of heat exchangers that are used for water system. The first one, double shaft condenser, that is this one, cover and coil condenser. The second is cover and tube condenser, and finally evaporative condenser, this one.
Okay, the other kind of the part of the exchanger is the economizer for boilers. The economizer for boilers is basically a equipment that heat up the water. It's placed in the chimney of the boiler. They transfer the heat that produces the gas combustion to the feed water of the boiler, and reduce the allowing. Full saving of about 5%. You asked that what the economizer to bring. Basically, the economizer do is decrease the temperature of the gases to in between 19 Celsius and 113 Celsius. In this case, the economizer decreases the temperature of 216 Celsius, 130 Celsius. The advantage is that the thermal shock at the free water decrease because the water is the temperature is increased. The decrease of the temperature due because has to have according the legal regulation. The greenhouse gas emissions are reduced by 5%, and the economizer are relatively easy to install, and the maintenance is very easy because the parts are easy to move. Kinds of economizer are rectangular or cylindrical. The rectangular have a vertical horizontal flow is from 15 psig to supercritical pressures, and is from 1,000 pounds per hour to 1 million pounds per hour. The cylindrical has a vertical horizontal gas flow, is for boiler to 3,450 pounds per hour to 10,000 pounds per hour, and olive all over.
Now the chief part of this presentation is closed feed water heater. A closed feed water heater is used in a conventional power plant to preheat the boiler feed water. The source of heat is a steam blade from the turbines, and the objective of this process is to improve the efficiency of the thermodynamic efficiency of the site. Now the description of this equipment is shell and tube type, heat by turbines, don't require separate pumps, and feed water passes throughout the tubes. You can see in these images a closed water here that is in the middle of the image, and the whole process is the Rankine cycle regenerative. You can find as you can see in this slide, there are the advantages and disadvantages of the equipment. Disadvantage is most expensive than other equipments, and advantages reduce the reversibility in the steam generation. It helps avoid thermal shock to the boiler metal, and finally springs need to be at the same pressure to be reversible limits.
The other kind is the boiler preheater. The boiler preheater is a cylinder that is tube shield using high pressure steam, heavy fluid extract from the high or medium pressure turbine. Basically, this is placed behind the water tank, feed water tank, condenser the rises again. Normally, the medium or high pressure turbine are joined in series, but other combinations are possible. Basically, distract the heat of the steam from the turbine, and the heat is transferred to the water. The advantage is that the combustion is complete and increase the efficiency of the boiler. A disadvantage is a strong corrosion that is inside of the gas combustion. The kinds of preheater is recovery and regenerative. The recovery, in this case, two fluids are between a steel plate that do the heat transfer possible, have two kinds, that is plate or tubular. The plates they consist of steel sheet elements in the front of box, and tubular constitute a vinyl tube enclosed in a cover with one or more partitions to obtain the cross circulation of the same. The surface is heated on both sides by fumes and internally cooled by water. At each turn of the rotor, a complete heat exchanger cycle is attached.
So now we are going to see. We are going to show a video about the thermoelectric power plant.
Our process uses Powder River Basin coal from Wyoming. The sub-bituminous type coal as a fuel source. When the coal arrives at our plant by train, we use a trencher and a series of long conveyors to stack coal in our yard, move it to the storage silos, or send it directly to the plant. We try to keep a 37-day supply of coal, about 1.4 million tons, on the pile in our coal yard, and up to 40,000 tons in silos. Since we burn as much as 38,000 tons of coal in a 24-hour period, we need to ensure we have a substantial amount on hand. Coal moves into the plant on a conveyor and is stored in a series of silos, each one leading to a feeder, pulverizer, and ultimately to the boiler. At Plant Miller, we have 4 generating units, and each unit has 7 silos feeding into one single boiler. The coal within each silo falls into a feeder, which measures and controls the flow of coal into a pulverizer. Inside the pulverizer, coal falls onto a large rotating bowl, where it is continuously crushed by 3 large grinding wheels until it becomes the consistency of baby powder. Once the coal is a fine powder, it falls off the grinding bowl and is carried by warm primary air, maintained at 140 degrees Fahrenheit inside the pulverizer, to the boiler through 8 burner lines. When the particles of coal reach the burners, they are mixed with secondary air that has been preheated to over 500 degrees to support complete combustion inside the boiler. The combustion of the coal converts its chemical energy into thermal energy, creating heat.
Now we are going to explain the process that is thermoelectric power plant. The first part is full circuit. The fuel is formed in the boiler. The fuel in the boiler consisting of an enclosure enclosed by walls of masonry, in which generally are the circulation channels of the air necessary for the combustion of a natural gas. That means carbon. After heating the boiler, where water vaporization takes place, the combustion waste gases or fumes pass into a loop to be removed outside. Since these gases are still hot, the thermal energy contained in them for the primary circuit of one or more steam reheaters and for the primary circuit of one or more can be used economized for the boiler feed water.
So the water evaporation takes place in a tank that is inside the boiler. So the water steam goes into these red pipes with a high pressure that is 2040 psi and a high temperature that is 100 Celsius. So the steam water goes to the pipes until the turbine. In the turbine, the steam expands and the steam generates enough mechanical energy for the turbine start to move.
Superheated steam from the boiler, which is approximately 2400 psi and 1000 degrees, travels to the high-pressure section of the turbine, where it creates the force that turns the turbine shaft. This process causes the steam to lose temperature and pressure, so it must be sent back to the boiler to be reheated to 1000 degrees. After reheating, the steam returns to the intermediate turbine and continues through the crossover into the low-pressure turbine. The force of the steam turns the turbine shaft, which turns the generator rotor at 3600 revolutions per minute. This rotation, along with the induced current on the rotor inside the generator, produces voltage, completing the process of generating electricity. The generator output is 24,000 volts, which is stepped up to as much as 500,000 volts for transmission.
So, on the outside of the turbine, of every turbine, there is some condensers. In these condensers, the hot fluid is the steam, and the cold fluid is the water that is in the tower cooling. So, after the condensation, the water is returned to the tank of the water and the process starts again. And this is the cooling tower.
Let's take a closer look at the circulating water the plant uses, starting at the cooling tower. Cool water is pumped from the cooling tower basin through large pipes to the condenser to absorb most of the heat from the turbine exhaust steam, leaving us with warmer water that must be cooled. So the warmer water is circulated back to the cooling tower, where it enters through riser lines to the top of the cooling tower fill. As the water cascades down the cooling tower fill interior, it's air cooled, allowing the heat to escape up through the natural draft cooling tower. The cooled water is collected in the cooling tower basin to be recirculated back to the plant to condense more turbine steam exhaust.
Okay, finally, the electric energy is produced by electric machine and is driven by machine or high pressure stream. The stream power to generate the energy require very high energy. And thanks.